Hi everyone, welcome back to this channel. So I decided to randomly experiment with making my own programming language, just because I want to see what it's like and just had kind of a curiosity about it. I originally made it in C# and I wanted to port it over to Zig, and I realized it could be pretty educational what I'm doing. The problem with Zig is you don't really have, say for example you make C++, for example you make a class in C++, and the class has a string and something like this, and maybe you make a vector of a struct, and the struct contains a string. The problem with this, well, in Zig, is that so in C++ you just call a destructor, and it would basically just free the memory for you. Basically, it's called RI. You don't have this in Zig, and you basically have to manually delete everything. So I'll show you what I mean. So basically, all I'm doing is, so I take my language or whatever, and I parse it into tokens, which I wrote all myself. I'll show you what that looks like. So I have this thing parse with loads of parse errors, but ignore that. Load of imports. I use the allocation tracker because basically my tracking allocator. I was getting a memory leak. I wanted to see if what was causing it, or if I had any memory leaks or not. It basically just puts a allocator into it and then just tracks the memory with allocated bytes as a U size, and then you print. You can look up how to track memory. I made a video about that. Anyway, so in my parse function, basically, so we create the list, and what a list is, it's basically a custom array list. The problem I have with array lists is you have to use iterators with them. You can't just simply say index 0. You can't do this. You've got to use iterators, which I find so annoying, and it just doesn't work in this project. I don't want to loop through everything. I want to see, at this index, is this that? I don't want to have to loop through everything to do that. So basically, I created my own custom list, which is basically, it's an anonymous struct, which takes in a comp time t of type, so it has an array of types. It has a capacity and a count. The count is how many you have, and the capacity is how the possible of, say for example, by default we add 5, and then say we add 1, if we count to 1, count to 2, count to 3, and if when the count gets to 5, then we increase the count by another 5. That's basically how it works. And this you could just use the indexes, so you don't need to use for each loops for this. So that's basically it. So yeah, basically all you do is you type in list token, and then you create it, and then that's all you need to do. Then, for example, create. Oh yeah, just creating that. It's just a token. Sorry, it's a pointer. The one problem I had was I had a memory leak, and the main reason was I wasn't using a pointer here. So you have to basically have a pointer of a list to pointers of tokens. And what a token is, it's a text. It's text, and it's a type. And it's a line number for U size. Line number is for debugging, basically. What line number was it on, so you can show the line and show where the error was if there's an error. And the token type is just a massive list of types or possible things this could be, basically, all from my language that I made up. Basically, what I thought for like a programming language is something like, it's like a joke. It's called C-. It's basically like C, but with less features. But very simple and very kind of, it's not high level, but kind of, it just, makes things kind of easier. It's just an idea. I'm not actually like not like a serious project or anything. It's mostly just to experiment. I'll show you what my language looks like. It would probably be hard to see because I have, say if I go to code samples, it looks like this. Like, what is this nonsense? But if I print the code, I'll show you all this later. Anyway, does it show the code? It does not. There we go, it shows the code. So that's basically what my language looks like. There's FN, I32. I like I don't know why like modern languages like to do this, but the modern languages like to do something like name, type, which I don't like. I just don't like it. I prefer the C++, C way and C# way of putting the type first and then the name. I like to do that, so I do FN I32 number. That's basically it. And print line. It's very simple. It's not really a complicated syntax at all. It's very similar to C++ and C. Anyway, so I had memory leaks. I'll show you what I was doing. So parsing, I had lots of memory leaks, basically because I didn't make things a pointer, which you had to make a pointer. So here we go. So we have last token null. So basically we go through every character. We have some checking here, which is basically just like, so if there's a comment, I had some problems. This is kind of just a workaround. If there's a comment, so I just get rid of that. If it's a new line, obviously, if it's a new line, we just skip because we don't want to resave a new line. But if it was a comment, then we have to save that as an end comment because I didn't know how to kind of track when the comment ended. So I just have you start the comment and then end the comment so I know when it starts and finishes, and I'm not, you know. But yeah, it's kind of an edge case, that. But basically all I'm doing is I go through every character, right? And then I see if it's a skippable character, like if it's a space or if it's a new line, you should skip. Then I get to the token, so I call get token. First we create a buffer with max size, which is 100, so the max token size is 100. And then we basically just loop through every character again, and we add to the index. So we basically pass the index, where is it? Line count, current string index here. We pass that as a pointer and we add to that. So say, for example, we find, let me open. Say, for example, okay, so here we go. So we find F, okay, and then we got to go from F to Fn. And then, oh, this is a space, okay, go back. And then, oh, this is a space, okay, go to the next one. That's basically what we're doing. And we save this. So we loop through, see what we need to do. I have a load of actions, basically just depending on what the last character was, if we should return, if we should break, if, you know, if we should return an unexpected error. We increase both of those, and then we allocate space for based on the buffer size. So we allocate using the allocator, basically the current buffer size. Then we copy that. I could use memcopy. I couldn't be bothered. It's just not that hard to write a for loop. Get token type. So the get token type basically just uses st equals and sees if it's fn, tag it as a function. If it's an if, tag it as if. I'm just tagging it. That's all I'm doing. And then I create the token. The problem you have with this, so for example, the token is basically it's an enum with a type, a usize with a line number, and it's a link to a string or a character array, a slice. That needs to be on the heap, and also the token needs to be on the heap. So we have a list which points to a token, and the token points to an array of characters on the heap. And I have to free all this, and I have to manage it all. In C++, you just use a destructor that does it all for you. But I have to do this, which is why I'm using the allocation tracker, so I can track this and actually see how much if I have a memory leak or not. Because before, I was not doing it the right way. Okay, so we create the token, we return the token, right? And then back in the function, so we get the token here, and then we basically add it to this, and I'm adding track. I have basically multiply. I have add without the track, which has a regular allocator, add with track, which has the tracking allocator. That's pretty much all I'm doing here. So I add it to the list, and then I set the last one to this, and then I just return the list. And then back in the main function, we just print the list of tokens, which shows this. So for example, we have fn, which is type of fn as line count 0. I32, which is type of I32, 0. Get number, which is I guess potential variable name. I'd basically call it potential variable name if it could be anything. So it could be a function, it could be a variable, could be an error of some kind, it could be a comment, I don't know. I just call it potential variable name just for anything like that. Left bracket, right bracket, left brace, and then basically all I'm doing. This is a token type return. That's all I'm doing. I'm just tokenizing. That's all I'm doing. And you could say, there is a tokenizer in Zig. Why don't you use that? I want to write things myself because you learn the best way when you write things yourself. If you just simply say for example a Python tutorial on a neural network. What we do is we import tensor and then call a function. How does the function work? I don't know. We're just using a library. That's the whole problem with using a library and using Python. You don't learn anything. You're just using what someone else wrote. So I would rather learn things myself by writing myself and then experiencing the errors and the kind of the problems you have. You'll understand it a lot more if you write things yourself. which is everything here is all written myself. Like I didn't, get this anywhere. I wrote it all myself, which means it's probably bad, but I don't care. Anyway, so what I need to do next is basically format it into a... what I'm going to do is I'm going to convert this into LLVM. An LLVM is pretty complicated, actually. It's not exactly like simple language. LLVM is basically... It's very similar to... it's kind of like a language that's almost similar to assembly, that is basically platform like it doesn't really matter what platform you're on, it will compile. But before, what I was doing was I was converting it to C++. I'll show you what that does actually. Open language compiler. So this is originally written in C++, in C#, just because it's the language I'm most familiar in. What am I doing now? Raw assignment test. Let's do template 6, maybe. Maybe grade. Let's do grades. I'm not sure if this actually works at the moment, but this will convert into C++. I'm pretty sure, if things are working. That is, if it would not take 10 million years to load. Right, yeah, I have a semantic analysis that I was doing at the moment, and I need to turn that off because I haven't actually got that to work yet. So I'm just gonna not call semantic analysis so I can actually show you how this works. Where the hell am I? Check code. So I'm just gonna get rid of this. All right, skip the semantic analysis and just print. So basically, we take this. So we take this. I'm just going to copy this and show you what it looks like in Notepad++ and get spammed by all the crap I had open. So this is my weird language, I guess. It's not really a language, honestly. This is anyway. So I had support for int and i32, so they're both optional. You can i32 or int. It doesn't matter. You can use both. It's completely your choice, whichever you want to use. Basically, I want to print this. I want to get this. It's just, some grades about some students or whatever. It's just a good test to use because you have loops, you have return statements, you have casting, you have lots of things. You have arrays. You have lots of things to test, basically. And this code converts into this C++ code, which basically what I do. I'll create a new one and do this, and then tag this as C++, which I can't find. There it is. Tag it as C++. So basically what I do, as it's obviously the formatting is garbage. I haven't fixed the formatting because it's kind of annoying to say, like, what was the last character? Okay, if the next character is a square bracket, then don't add a space. It's like, I can't be able to do it yet, so I could just do it myself like this and not have annoying formatting. Doesn't matter. Anyway, this shouldn't... Why has this got so many misspaces? Anyway, so this converts into this. And the thing, one quality of life thing I did was I basically just take every function definition, put them at the top. You don't have to copy them anymore. It just does it. Put them at the top, does it for you. I also added the defer keyword if you wanted to have that. Also, this indenting is garbage. I don't know how to fix that. It's something to do with tabs, I guess. Doesn't matter. Indenting's not the greatest, and the formatting's not amazing, but in theory, the end user wouldn't see this at all. But, I mean, the thing is, we're converting from... I shouldn't say double. I'm sorry, this is C++. It's F64 in my language. In theory, like, the end user wouldn't see this if you were actually, running this. It's a lot easier to convert into C++ than it is to convert into LLVM, because I'll show you what LLVM looks like. Alright, so this says, I believe, hello world in LLVM. I'm not sure if you can even put this into C, whatever. I don't know. This is what LLVM looks like. Like, what even is this? Like, this literally just says hello LLVM. This is not simple to convert to. So in theory, that's kind of the the end goal is to convert this into LLVM, not C++. But C++ is this is a very easy thing to get working. This is pretty easy to run. I mean, most languages actually convert to LLVM, like C++ and C convert to LLVM through Clang. Zig converts to LLVM. Rust converts to LLVM. But yeah, you see this. So here we're calling. What are we even calling here? I'm not even sure what this is doing. Print call i32 at print. I can't even read this, honestly. It's a complicated language. It's not exactly, you know, very readable by most people. Also, if you look at for loops are not simple at all. They have blocks. You have like the condition block, and then you have the iterator block, and then the end block. So yeah, it's not that simple. What people normally use is they use C++ because C++ LLVM is written in C++. So what they do is they basically just converts it for you, generally, using their own functions. But I'd rather do things myself and learn, because that's the best way to do it. But I'll show you what I had before. So before I had memory leaks. Where are we? We're on main. I basically had the allocation tracker and I wasn't freeing properly. So I'll show you how I free things. Basically, I have this free memory track. I'm using the tracking allocator here. So obviously, I have the regular free memory, which I need to update actually to... Yeah, it's fine. Okay, so memory free track. So basically, I need to free. So we have, if I show where the hell are we? This is a token, right? So inside token, we have a const u8, token type, and the usize. But you really need to free this because the text is on the heap as well. So I need to free that. I don't know where I am at the moment. List, okay. So I need to free that. I need to const cast it because you can't. The problem is it takes in a slice that's not const, a non-const slice to whatever the type is, and it's a const. So I have to const cast it to a non-const. I don't know. The compiler complained at me. So I free the string, and then I free the token, and then I free, I guess, the data, which is the actual all of the token lists, and then I destroy the list itself. I think that makes sense. Anyway, so if I comment this out, I'll show you a memory leak because I didn't free all of it, what I was getting. You see here, we have a memory leak, right? We have 1,422 bytes before the free. Also, I probably should use defer, but I couldn't be bothered. Basically, the problem with defer is I have to work out which goes first. Does that go first, or does this go first? I think the top one goes first. I don't want to think about that, so I'm just going to put it at the end. So 1,422, and we have 1,110 at the end of it, so we didn't free it. That's the problem. So I needed to free it here to avoid having a memory leak. I also like, say for example, if you forget to do this, then you'll still have a memory leak, and it's like, of course, in this situation, the memory leak probably wouldn't matter. You still have 1,024. So we need to free everything, and then no memory leaks. This is basically why I use the allocation tracker, because this is a complicated project. But one of the main reasons I made my own custom array list is because I hate, like, you have to basically, you couldn't do this. You can't do this at all. You can't go data by index. It won't work with an array list. With an array list, you have to do this. You have to go something like, I don't even know how you do it now. Maybe just 4 token list? I don't remember how you write it. Yeah, you do this, and then you capture a token. That's the only way you can do it. This is basically, I might make a series out of this. I'm not really an expert in doing this. I'm pretty much an amateur, but it was just to learn, and it's also just kind of gives you some information of how to the kind of some difficulties with actually working with Zig in lots of actual real world applications. If I show you, for example, if I show you template 6, or do I have grades? Grades, okay. Let's do grades. Grades is actually a big application. We'll get an absolute spam of tokens. This is what basically all programming languages do. They tokenize it into this. So here we're allocating 11,000 bytes. which isn't that much really, but if you know, it's a decent amount of bytes, I guess, and then we have to clear it all. Obviously, the bigger the code, it's not even that complicated of a code thing. Also, basically, what programming languages normally do is they create what's called an AST, which I kind of avoided doing at the first, and I don't really like object-oriented programming, and you have to use inheritance to use an AST. So I basically just created my own kind of way of doing it. So I create a code format which holds everything, and I'm actually using composition, I guess, for once, which I don't really like to do, but it just fits for this. So I create a function node, right? And the function node is normally I guess it's a struct on its own, but basically it's not the way normally people do, because basically what people do is they'd create an assignment node, and then they'd create a declaration node, and then they're all different structs. I didn't want to create like 25 different structs and just like, no. What I basically do is I tag the type. So I have I don't actually have code blocks written here, so I'll have to do it in C# version. AST variables, close all the nonsense. So I created a function which has a var type, the name of the function, obviously let's say if it's main or whatever, the parameters, there's a list of tokens, and then a code block. And what's a code block? It's got a node type. What is a node type? It's basically, what is it? Is it a function? Is it a variable declaration? Is it a return type? So you know what it is. So yeah, a node type and then a var type. Basically, if it's an i32, I need to set whatever the equals is to an i32, list of tokens, and then another code block. So the reason we have another code block is because it could be an if statement, it could be a for loop. So basically, you have a function, you have the declaration, and then you have the code blocks, the blocks of code in between the curly braces. And then you could have an if statement, which has its own code block. But sometimes they don't have their own code block. If it's like, a variable declaration, it wouldn't have its own code block. So you don't do that if it's that, but you just have it there just in case it needs to exist. And I basically just work it this way and don't create 25 different AST classes, because I hated doing that. And just do it this way. I just haven't implemented this in Zig yet, which I'll do later. Anyway, I'll probably maybe make a series out of this if people want to see this. It's also pretty interesting. I could probably make a video of how to make your own language as well. Basically all you're doing is you're just transpiling it into another language, or you're transpiling it into LLVM, or you're transpiling it into machine code directly, or into assembly. That's generally all you do. That's basically what I've been working on for like 2 weeks. But I'll see you guys next time.